Yes. So DevSecOps by default, I try to make up some time here. My name is Andreas Grabner. As you can probably hear, or maybe not hear, I am from Austria, I just mentioned it. And I'm very happy to be in Amsterdam. In my world, I've been in software engineering since 1999. Hard to believe because I shaved my beard this morning to look a little younger. But when I started my career, I started as an engineer. I was actually a software engineer on a testing product. Then I became, in our organization, actually a tester on the testing product before I became an engineer again, because software quality was really important for us. So for me, software quality is a big thing. For the last 14 years, I've been working for a company called Dynatrace. We do observability, so the stuff that was just presented earlier is something that I do in a day-to-day business. Distributed tracing, logs, metrics, user behavior. I call myself a DevOps activist because I want to make sure that we really get observability into the DevOps pipelines. On the other side, I'm also a DevRel and a maintainer of the CNCF project Keptn. I tried to make it obvious, Keptn obvious, that I am part of that CNCF project. We just reached incubation status. So if you are familiar with CNCF, the Cloud Native Computing Foundation, that's the whole organization that emerged out of Kubernetes. We are now an incubator next to tools like Argo and others. By the way, OpenTelemetry, the speaker earlier mentioned it, OpenTelemetry has now surpassed Prometheus as the second largest project, most active project in CNCF. So it is really the future when it comes to observability. Security is a big topic for me. I, however, am not a security guy, to be honest with you, but Log4J was big for me as well. And this is why I actually looked into the security and tried to figure out how can we bake and make security part of DevOps. And also, what can we do as the open source project Keptn to help you build platforms that are automatically validating security across your lifecycle. Quick show of hands again, who had to deal with Log4J? Because a couple of people, yeah. For those that have not raised their hand, there will be hopefully some inputs and pieces where you actually learn what this was all about and why, what we can learn from it, and also what we can do. First of all, I should not need to remind you that any bad code quality is bad for business because it costs more the later you find it, and security is just even worse than all of the stats that we have known for bad software quality when things crash are not available. Also, the thing is, security by default, securing systems and providing secure systems is really hard. I work for Dynatrace, as I mentioned. We are 1,000 people in R&D globally. This is just a snapshot of our dev environment, so about 1,400 hosts that are flying around somewhere in the different clouds, and we do 4 releases a day in our kind of internal dev environment. It's really hard and scary for our security people to actually make sure that even these systems are secure and have no vulnerabilities. So a lot of change happening. So my talk today, I want to give a quick recap on Log4Shell because this was a compelling moment that really, I think, brought security back on the map for everyone. Also for those people like me that didn't, I think, give it enough attention. I will then talk about how to detect vulnerabilities, because I looked into some of the things, how we can detect vulnerabilities right now, and I think there's some things, especially that observability brings in, how we can make it better. Then I want to talk about what I mean with DevSecOps by default, so how to inject security into your complete lifecycle. And then at the end, I want to show and talk a little bit about the tooling, and this is where kind of Keptn comes in, the CNCF project. First, a quick recap. Log4Shell. The internet is on fire. These were, I mean, a lot of you raised your hands earlier. You remember December last year, there was a lot of noise on the internet. Those people that were writing about it, and unfortunately those people like you that had to deal with it. And there's a lot of stuff happening. Quick timeline for those that are not aware of it. December 10, just shortly after midnight, so 12:40 a.m. UTC is just shortly after midnight. It was reported. It was then picked up by the NVD security database a couple of hours later. Then tools like Snook, I'm sure there's others as well, they also picked it up. They made an assessment of the situation and assigned it with a certain criticality. And then there are tool vendors out out there today as well. I think we have seen a couple of sponsors on stage that are also like we as Dynatrace. We have an AppSec solution as well as part of our observability platform. We are pulling this data in, and then we're trying to figure out, do we actually, based on observability data, see any systems where this vulnerability is present? Are there any servers? Are there any Tomcats, JBosses, where this library is loaded? And then, oops, too fast, then we report it back, at least to our users, and I'm sure other solutions do it in a similar way. But you can see the time spent was really short from reporting it until security tools have picked it up and probably paged a lot of people of you. So, for those that are not familiar what the vulnerability was all about, typically when you have a web application and somebody is trying to access your website, then most modern web servers, app servers are doing some type of logging. And you log out things you can see here on the top right, the HTTP header, your URL, maybe also the user agent string. This is just regular practice, logging requests. Now with Log4J, the vulnerability, this allowed attackers to put some malicious code in there, because Log4J, the vulnerability, was not just dumping out the incoming request or the strings, the characters individually, but it was actually executing it, which actually allowed attackers to force Log4J to actually execute code because of some of the vulnerabilities that were in these particular libraries. There's a really interesting sample project on GitHub. I want to give credit to this guy. It's called an Insecure Bank sample app that was actually is a showcase that you can run and you can actually exploit it or can figure out how it works. Once you run it, you can just use a malicious username when you log in, and this username, as you would normally do in a regular app, you would probably take this information and log it out to disk. If you use Log4J, with the vulnerable version, it will actually execute this particular code, which means it is downloading an additional Java binary into that same Java process, which then opens up great opportunities for backdoors. So this sample app is a really great kind of showcase on what these vulnerabilities can actually do. All right. So again, the credits go to github.com/hdiff/insecure-bank. A really great help for all of us to understand this a little bit better, right? And the backdoor, again, it's a sample app, but still, once you can run your own code in the target system, you can do whatever you want, whatever privileges the process has. All right. So, scary, right? But what it shows us, this is just a bigger problem. Or, let's say, Log4Shell just shows us that we do have a bigger problem, because Log4Shell is not the only thing. You have probably a lot of complex systems. And we saw early in one of the sessions this cool animation with all the dependencies. This is the way we, on Dynatrace, show the dependencies when we are doing observation of our customer's environment. And a lot of environments are really complex, much more complex than this. And the challenge is these environments are constantly changing, and on the other side, you have constantly new vulnerabilities. Whether it's Log4J, or also I think the latest one from a couple of weeks ago, the Confluence exploit, which is a great product that we all love, all the tools from our vendors that make us more productive, but also these tools are subject to vulnerabilities. And then you need to know, do you run this particular piece of software with that vulnerability? But in an ever-changing system, it's really hard to do so. So how do we detect vulnerabilities better? And with better, I mean, the problem is, like, what was the character's name from the last presentation? Bill, who got woken up at 2 o'clock in the morning. If Bill gets woken up at 2 o'clock in the morning and the security tool tells him, you have 1,522 vulnerabilities, that's going to be fun, right? So what does Bill do? Well, let's say, why do the traditional tools actually come to these conclusions? Because traditional approaches, and I tried to do some research my own, again, I'm not a security expert, but one of the approaches would be file scanning, right? If the report comes out, do we actually have these vulnerable libraries on the file system? Maybe searching for file patterns. But honestly, this does only tell you if this binary is on the disk. Doesn't tell you anything. You can start cleaning everything up, but then you don't know what you destroy. So a better approach, even not perfect, is to at least look, are these libraries even loaded? Because if it's just somewhere on the file system, it's not actively loaded, who cares? But even if it's loaded, it doesn't really mean that the vulnerable code is executed. Log4j is a large library. It has hundreds of functions, but maybe only one or two, if they're used with a certain parameter, are actually vulnerable. Therefore, and coming now back to the previous presentation with instrumentation. Instrumentation-based, or instrumentation, whether it's done dynamically through agent technology that monitoring vendors are doing, or open telemetry, really give you the chance to say, I'm instrumenting those vulnerable code, those vulnerable pieces of methods, and trying to figure out if these methods are actually called. This is just a screenshot of one of the tools where you can, through configuration, say, hey, there's a new vulnerability. Now I want my observability platform to instrument that particular method, and I want to see at runtime if it's actually called. Because if not, it is less of a risk, because maybe your code is not even using that library in that way. Another thing is a pattern. A method might be vulnerable, but only when certain method arguments are passed in, like the malicious string that I showed you earlier. So if you have instrumentation and you can capture method arguments or return values, then you can also do pattern detection and figure out which of your systems are not only using that function, but are currently being exploited by somebody really trying to put malicious data in. Next thing is, what I love about distributed tracing is, if you find a component where a certain method is called that is vulnerable, and if you do distributed tracing right, you actually get the trace started from the end user, or at least where the request enters your system, which means you can then do a so-called backtrace. You can figure out, like if you have a Java service, who is calling that Java service, and from which IP address does it come from, or from which region, from which user. So this gives you a little bit more insights about the attacker. Right? So it's very powerful. Next thing is, if you know that you have a vulnerable system that is loading and executing this particular code, there's still something that you need to differentiate. Because on the one side, you may have a host that runs insecure code, but maybe it's completely shut off. Maybe nobody else has access to it. Then it's less of a risk than a system where you have a host that maybe runs some, let's say, not really business critical app, but if that server, that host, has the vulnerability and somebody attacks it, and this host has access to another machine in that same environment with a sensitive database, then this is much more risky than the stuff on the left. So really what this is all about is trying to use observability, trying to use dependency information, runtime dependency information to make better decisions of, is this really the most critical thing to focus on, or should we rather focus on this? Does this make sense? Yeah? Okay, so remember, if Bob wakes up, he should never wake up to this, because what Bob or whoever your security team is, they should ask 4 questions. First of all, do any of my apps actively load this library? Because if it's just on a file system, it's never get loaded, reduces the risk. Second thing, does it actively execute that particular function that is vulnerable? Or is it using just other parts of that library that are not vulnerable? Are those apps even an open target, or are they in the backend already closed off environment? Then it's less of a risk, because I would focus first on things that are publicly exposed. And the last thing is, are the hosts that are connected or that are impacted by this also connected to sensitive data and have connectivity there? So these are the 4 questions I think that you should ask yourself if you're trying to do, make your security better. First of all, well, these are great questions. You have a lot of data, hopefully, in your environment already where you can answer some of these. There's also existing security tools, both open source and commercial, that are already doing these things out of the box. Right? I also added we have a lot of vendors here also in the space, here at the booths, that are providing also security capabilities that are similar to this, so check them out. So you don't have to do everything yourself. The point though is, if you do it, we're getting rid of looking at 1,500 vulnerabilities, and we can focus, let's say, on the 7 or 10 that are really important. Right? That's the idea, because we all have limited resources. So this is how I think we need to think about better detecting security vulnerabilities. Next part for me is, how can we automate that into the DevOps cycle? And I know I had a couple of conversations earlier during the lunch break, and those people that I talked to that are already doing something with security, I think this is all clear. What we can do is, as let's say a container or a binary comes and kind of gets pushed through your pipeline, we have obviously container scanning tools, right? Static scanning tools that can detect vulnerabilities based on libraries that are baked into that container. This is great. You can already find certain problems. As you're moving this container from your container scanning, maybe in your test automation, where you actively load against it and run your tests, you can also define any dynamic problems. Because not every code that is in the container is the final code that runs, because if things get loaded dynamically, right? So you can hopefully, with good test automation and then also using security testing tools there as part of your load testing, your functional testing, hopefully find and remove all of the security holes before you actually push it into production. That would be the ultimate goal. Okay? But this is not the end of the story. Because even in production, it's very important to do continuous scanning, because Log4J was found in December, but the vulnerable code has been in there for much, much longer than December. This is why it's important that we never stop scanning. We never stop looking for security issues. And again, then the question comes up, well, which of my 1,000 hosts are really important? This is where my 4 questions come in from earlier. Focus on those hosts that actually load that code, that execute these functions, that are exposed to the public or have access to any sensitive data. Right? Because if something comes up, we want to remove it. So, last piece of my presentation is now, how can we provide some more automation around it? Because I assume at least, a lot of you have great tools. You have CI tools, you have CD tools, you have some testing tools, you have some security tools, you have some observability tools. But how can you all put this together? And maybe there is something that actually makes this easier. And I think the tool that we have for you, an open source project, Keptn, tries to solve this a little bit and makes it easier for you to implement DevSecOps by default. So first of all, what is Keptn? If you've never heard about Keptn, Keptn was donated by Dynatrace because we implemented this internally to solve a couple of our automation issues and also bring in observability kind of at the center of everything we do when it comes to pushing stuff through the pipeline and keeping it safe in production. What I like a lot is Tarash. He's a performance engineer at Facebook. When he saw Keptn the first time last year when I gave a presentation, he said, as you can read it for yourself, it feels like a reference implementation of Google's site reliability engineering practices. And I added this in here because in the morning, in the presentations, SRE and SLOs were mentioned, and this is really at the core of Keptn. So, at the core of Keptn, Keptn uses SLOs, service level objectives, to validate the health of your environments and of your apps, actually the desired state, because the desired state of any app is it should perform, it should be functionally correct, and it should be secure. So what you can do with Keptn, we have a so-called lighthouse service. The lighthouse service is there and can be fed by your objectives. The objectives would be, and actually let me see if this actually works here. Here we go. So you can specify, and this is also obviously very hopefully developer friendly. Your developers or your architects can specify what your objectives are in terms of performance, in terms of memory, but also in terms of security. For in this case, I don't want to have any critical security issues in my system. Now the question is, where does this data come from? Keptn pulls this data from your observability platform. So you have an open interface and open integrations with existing tools. You can also write your own. And in those tools, you have to specify how you can, for instance, query the critical security problems. For instance, Falco is an open source project that detects security vulnerabilities by looking at eBPF. And it is exposing security detected problems through Prometheus. Dynatrace does it in a similar way, or I'm sure SonarQube, Snook, and all the others do it in the same way. So you're specifying how you query the data. Keptn is then pulling the data in from these tools and then is comparing it against the objectives. The nice thing with this, though, is we're separating 2 concerns. How to get the data, from where do I get the data, monitoring data, performance, security, whatever, reliability, and then what is my objective. And then we analyze it, and for every time you ask Keptn to run a scan, it gives you a total score across all of your objectives. So to give you a quick example, SLIs, I got 1, 2, 3, 4, 5 SLIs. Response time, failure rate, response time of a particular transaction at the very bottom, security vulnerabilities. Then you specify your SLOs. Remember, these are two things you have separately configured in two YAML files. You can specify targets, pass and warning, where you can combine an absolute threshold and also relative. Relative means to the previous builds, to baseline. And you're specifying an overall target. What do you consider your build to be good? Now, if the first build comes along, the first container, you can then say, hey, Keptn, please run my evaluation for build number 1. So Keptn reaches out to your observability platforms, to your security tools, pulls this data in, and calculates a score. In this case, it's a perfect score because all of my metrics are great. We get a new build. Build number 2 comes along. Build number 2, since it has an architectural regression, because our login transaction now makes more service calls to the backend database than we anticipated. Our architect said it should not change. So we're getting penalized and therefore thrown back to the developer something is wrong. Fast feedback, developer fixes the code, runs it again, fixes the performance problem, fixes the architecture problem, but introduces a security vulnerability because maybe in order to fix this, he upgraded to a new library of a tool that now has a vulnerability. Therefore, you're getting penalized, only 70%, not good, throw him back. Hopefully everything is fixed, developer gets a new build, and we're back on green. So this is at the core of what Keptn does, right? We're looking at SLOs that you can specify because SLOs are kind of like your desired state, that your system is green. It's a core component. Now, the big picture, and this is really what I like, I'm sure most of you are familiar with the concept of an operator in Kubernetes. An operator basically takes the technical desired state and applies it to your target environment and has a reconciliation loop to keep the technical desired state in Git applied with your infrastructure. What we are doing, we are raising this to a level where I'm basically saying we're putting the SLOs at the center because this is your real desired state. Not that you have 5 pods running or 5 virtual machines, but that your system is healthy and secure. So you define the desired state. Keptn then gets triggered if there's a new artifact available, let's say through Argo, through Jenkins, or whatever we have, or if we have a problem in production, let's say a new vulnerability has just been detected, and then Keptn can orchestrate delivery processes where it talks to different tools, and we call them automation sequences, and basically validates SLOs before and after it calls your deployment tools, your testing tools, your remediation tools, your notification tools. So we are providing an orchestration engine for delivery, but also for day 1 and day 2 operations. So if a problem comes in production, we can orchestrate your remediation tools, but always keep the SLO in mind and try to get the system back to a healthy state by calling all of your tools so that the SLOs go back to green. And how do we do this? We're doing this by specifying yet another open source standard. We talked about open telemetry earlier. Open telemetry is trying to standardize observability. What we are doing with Keptn here is we're trying to standardize the way DevOps tools talk to each other. So there's a project called Cloud Events in CNCF, and on top of that, a project called CD Events, Continuous Delivery Events, where we're currently working with the major tool vendors to finally standardize how we talk with individual tools. Because right now, most tools have proprietary APIs, which makes it very hard for you in your Jenkins pipelines, GitLab pipelines, to really call all of the tools and keep these pipelines running and not breaking. And so we have a couple of goals with Keptn here. The point is, the SLO is in the middle. And that's the big picture. And if you want to learn more about it, there's more stuff online. Most people start integrating just the SLO piece because most of you, I assume you already have some pipelines where you deploy, where you run some tests, so you can just then trigger Keptn to evaluate your SLOs, report it back to existing pipeline, and then, do the next stuff there, and step by step you can expand and give more control over to Keptn if you want to. So to wrap it up, what have we learned today? At least I hope you have learned something today. The first thing is the internet will be on fire again. That's just a given fact, right? It probably doesn't take 7 years again between hopefully it takes longer, but maybe not. But the internet will be on fire again. Don't drown in meaningless security alerts, right? Don't be Bill that has to wake up at 2 o'clock in the morning facing 1,500 vulnerabilities. Try to answer these 4 questions in an automated way and get down to a manageable number. Integrate this into your pipeline, and if you're looking for some tooling, then I hope at least I gave you one open source option today that can help you with that automation. Right? Keptn does not do security, Keptn orchestrates, but it provides standards to integrate all of these great tools into your pipelines. And with this, I want to say thank you so much, and if you want to follow up later, I know we are close on time, but I'm pretty sure with my name and with the rest of the information here, you can figure out how to get a hold of me later on, because I have to rush also out soon, unfortunately. Thank you.
Thank you so much.
Thank you so much.
Thank you.